Hey, all my JavaScript friends, this is the Virtual White, aka Mike Smith, and this is Fun with JavaScript, our racing series. This is video number 3 of building our tracks. In video number 1, we went through the math of how they were constructed. Video number 2, we constructed the track itself. And this video, which is video number 3, will show you how to construct both the starting gate and, if you can see it way down there, the ending gate. In fact, let me go ahead and bring that up a little bit closer view. In fact, there it is. So we'll be also doing this finishing gate. Nice pretty little gate there, and a stop gate for the cars. So without further ado, let's get to it. This is where we left off on our last adventure in building the track, obviously without a starting gate and an ending gate. And luckily those two are very easy to add in, so let's just get straight to it into the code. And here is our code. Add starting gate and add finish gate. Obviously the functions are not created as of yet. I just want to show you where we're going to place them within the main logic of the code itself. We need to have all of the different tracks defined before we put the starting gate and the ending gate on there, because we need to have both of them know, what's the start part of the track and what's the finishing part of the track. So that's why these two routines are located here within the test track live function. Now what I want to do here is I'm going to just comment these out, because obviously I just don't want errors to occur whenever we take a look at what we're doing here. So let's go ahead and add starting gate in first. We'll just add that at the very, very top here. Since it's called, we just put it before a track layout. Since it's called after the track is laid out, it doesn't really matter where we put it. But in any case, let's just pop it right there and let's pop some code in. And there's the first part of our code. And this just defines some variables we're going to be using. Basically, if you remember, we had two large black blocks that were placed onto the very top of the starting gate. And the idea here is that we're going to place the first block at a certain distance from the very beginning, and we're going to place the second block at the exact same distance past that very first block. And we're going to call them the upper gate and the lower gate. So just a couple of variables here. Black color, face colors. This is just something that when we create the block itself, this is how we're going to color it. Later on, you'll probably want to have some sort of material or something like that to represent some sort of starting line. I don't know, whatever you want to have. It doesn't really matter to me here. The important thing here is the size of the gates, the distance between the different gates, and any kind of gaps within the gate. So basically the idea here is that we'll have a gate. There's going to be a car that's going to be pushed up against it. We're going to have a little bit of a gap between the car, then they have the next gate, and then we'll have the next car which will be pushed up against that. So the important thing here is that we're going to, first of all, need to have a car length. And this car length basically is the number we're going to put in to say, hey, this is going to be the length of our cars. When we actually insert this into the game, then the car length will be determined by the different models of the cars. For right now, I'm just going to hard code. I believe 3 is what I hard coded. I can't remember. We'll find out here in just a minute. Here is the car gap, and this is basically the gap between the end of a car and the very next gate, or the end of a car and the very beginning of the track itself. This is the width of the gate, and this is basically the thickness of the gate as it is from one part of the track to the other. This is the height of the gate, and this is going to be the gate gap. And what this gate gap is this is going to be the distance between the first gate, or what we call the upper gate, and the lower gate. And that's going to be the car gap plus the car length plus the gate length divided by 2. Because whenever you create boxes or create anything like that and you give it a certain position point, everything's going to be built with the point in the very center of the box or the sphere or whatever. That's just the way FWJS works here. So basically, the gap between one piece of the gate and the other it will actually include half of the width of the gate. And the width of the gate is 0.25, so it's going to be basically a car gap of 0.25, car length, which I think is 3, plus gate width divided by 2, which will be 0.25. The gate width is 0.25. So car length is 3, car gap is 0.25, gate width is 0.25, so it's going to be 3.5 distance between each of the gates. So let's add that very first gate in. And there it is. And we'll be defining some variables here in just a minute. You notice there's missing variables, but that's okay. So we're going to create a box. It has a width of a gate width, height of a gate height, depth of the track width. The depth is going, because obviously we want it to go the entire width of the track. And then the face colors, which will give us that black color. That's what we defined right here. This is the position of the gate. It's going to start at the very first point which of the XYZ of the first point, and then we're going to add in the gap of the gate times the first point forward X. Now, why have we done that? Well, sometimes your track may start going down the X side. Sometimes your track may be going down the Y side, either both the positive or the negative. So by doing it this way, by both multiplying the X and the Y by the gate gap by the forward number, which is either going to be 1, 0, or -1, this will ensure that the gate gap will always be on the track itself, no matter which way the track is pointed. So it's very simple there. So in our particular case, everything starts out on the negative X side. So what's really going to happen here is we're going to have center.x plus the gate gap times -1, so basically minus the gate gap. So that's going to basically put the first gate on the X side, because our forward point is negative X, which will be a -1. Our forward Z for our Z position, our Z pointer on the vector for a negative X vector is 0. So gate gap times 0 is 0. So we're just going to take the center point Z and the center point Y. But notice there is a undefined variable here called Y slope. And this Y slope basically says, now we got to figure out the slope of the Y. And how do we figure out the slope? Well, we got to do the old slope definition of run divided by distance. How do we get run divided by distance? Well, we got to figure out the distance between the first point and the second point and do some funky looking math. Well, it's not really funky looking math, but let's go ahead and bring that code in there and show you how that works. And this is middle school math. So if you never went to middle school, like I didn't, then you go to Google and you try to figure it out again. So that's basically what I did here. I've got the first point and the second point, XYZ positions, and I've renamed them for my purposes here. FPX for first point X, first point Y, first point Z, second point X, second point Y, not SPY, and second point Z. So I got the difference between the two. FPX, SPX, X, Y, and Z. I got the difference between the two. And then I tried to figure out the run, because again, we're trying to figure out the run divided by the rise gives us the slope. And we got to be able to figure out the slope based upon either the X or the Y. So what I've done here is the distance formula is basically point number 1 minus point number basically point number 1 minus point number 2 squared and the square root of that. And the reason you do that, and the reason it's doing that is because, of course, one point may be positive, one point may be negative. So by doing a square root and then doing a squared, it all comes out in the wash. So that's basically what I've done here. Is once I've gotten the difference between these two, this is basically the distance difference between both the X, the Y, and the Z, and both the X and Y and the Z. What I've done here is I've done the distance formula, and I basically say, hey, if we're doing the forward vector X, then give me basically X squared, the square root of X squared. If we're doing forward Z, which would be the only other option because Y is not part, we're doing Y, we're solving for Y, so I don't care about Y, we just care about X or Z. So if it's not, if our vector is not X, it's going to be Z. So therefore we're doing Z squared, the square root of Z squared. And that's going to give us a positive number, which basically gives us our distance for our run. And so now we need the distance. Now we need the actual slope value itself. So the slope value is going to be the exact same thing here. Is going to be y diff doubled times, but y not doubled, y diff squared, the square root of that divided by the run, rise over run. That gives us the slope. Real simple. And I just realized I didn't have to do the math out absolute value because that's when I was messing around with it. But hey, that's just the way it is. Okay, so now that we have that, that now allows us to get this variable correct. We're taking the y slope divided by the gate gap because the gate gap is the actual distance that the first gate has moved. So therefore, by multiplying our y slope, which is our rise over run, by the gate gap, we're going to the gate gap representing either the x or the y, the x or z, the run. This will allow us now to be able to get the final y value, and so that gives us the y value itself. Bingo, no problem. Works like a champ. And I've also obviously I've done negative here because the y always is negative whenever you're doing in this particular case, the y is always going negative because if you don't have it negative, your cars are not going to go anywhere. So it's always negative. So that should place us the upper gate itself. Let's just go ahead and save it, and let's see if that gave it to us. There it is, and it's not there. Y is not there. Well, the reason it's not there is that we forgot to activate it down here in the bottom. Alrighty. Now, there we go. Add starting gate. That should do it. As you see here, here's my car length of 3. So let's Control S it. And there it is. That's our first starting gate. So that will basically mean a car length of 3 plus a little bit of a gap in back of the car, which means the second one's going to be about right in this general vicinity right here. So let's add the bottom gate in there. Let's go to the very top. I mean, what I call the lower gate, excuse me. And it's going to be exactly the same thing as the upper gate, except now that we're multiplying the gate gap by 2 each time. No big deal. All right, that should be it. Let's try it and see what happens. Perfect. Actually, my Y value may be a little bit off, but that's okay. This is, like I said, this is a proof of concept, so we'll test. We're testing it because it's a proof of concept. But there it is. That is our starting gate. So the idea here is that when we put this together with the actual track, is we'll add a little routine in here that when it gets a signal from an external source, it will drop the Y value by the height. Let's just go back to back over here. Our Y value is the gate height. It will drop the gate height by twice that just to be on the safe side. And by dropping that, that will immediately get that out of the way. And once it gets it out of the way, boom, we're done. Okay, and the last thing to add in here is the physics imposter, both for the upper gate and the lower gate. So we've got the upper gate in there. Let's pop in the lower gate. Instead of just going to my code and just copy and paste it, I'll just throw it in here. Lower gate, and it's no big deal here. We just give it some sort of friction, some sort of mass and restitution. The big thing here is to make it a mass of 0 so that the cars will stop up against it, or it won't fall through to the ground. So let me just save this and make sure that we haven't wrecked anything. Nope, yep, that looks great. Everything is still exactly the same. And I just did an F12 there and take a look at the debugger, and the debugger sounds good. So now that we got the starting gate, we need to get the finish gate in down there. Let's do that next. Okay, let's add the finish gate in. And now I've popped some comment code in here to basically, when I was doing this, is to remind myself, hey, this is what you want to talk about when you're adding the finish gate in. So I thought I'd just leave the comments in just for funsies. First of all, we're going to have 2 pieces to the finish gate. The first piece is going to be the hard stop at the very end. I'm calling it the stop gate, and that's going to be this black box that when the cars hit it, they're just basically going to stop. It's a way to keep them from falling off of the edge of the earth, basically in that case. The finish line is number 2, and that's going to be that checkerboard arch that is up and over the finish line with this green line at the bottom to be able to detect when a person has actually crossed the finish line or not. So first thing I want to do here is I want to go all the way down the very bottom, and I want to say add the finish gate. Let's go ahead and make sure we're actually putting the add finish gate in there so that I won't get confused when I try to refresh the browser. And let's put final slope here as the place I want to have my red dot. So if we just Control S that right now, I'll show you what that means. So we Control S, we go over to browser. So that's where my red dot's going to be. This is where our finish gate is going to locate. The black box is going to be located at the very end there. The finish gate is going to be where the red dot is going to be located. All right, so let's do it. Let's pop the stop gate in there first, because that's what I said we're going to do first. And here we go. This is very, very easy. I got a depth of 0.25. We've set up some stop colors here. That's basically is going to color each side of the box. Remember, boxes are six sides, so I've got 6 colors there. I got a stop depth of 0.25, like I said. I got the width of track width because I wanted to go for the entire width of the track. I'm going to create the box. That creates the box. The position, how do I want it positioned? Well, obviously I'm going to start at the very end of the track, and when I do add finish gate, I pass to it the next to last point and the last point. So I'm going to get to the very last point, which is this one right here, but then I need to move it. And where do I move it, or how do I move it? Well, first of all, I move it by, well, the only thing to move basically is the stop depth divided by 2. Now, why divided by 2? The reason or why anything right there? Well, the reason I did that was that remember that each position within a Babylon.js mesh is in the exact center of the box. So in this particular case, and I kind of explained this a little bit when I did the track in the last video, but within this, I know that I've got a depth of 0.25. If I was just to basically say, you know, hey, just put it to center X, center Y, and center Z, it's going to overlay the track by 0.125, or exactly half of the stop depth, because the point of the box, the point of the box for the position is in the exact middle of the box. So there's an equal amount of distance on the x-axis, the y-axis, and the z-axis. So I'm moving it by stop depth divided by 2 times the forward vector of the last point, either the x or the z. And again, remember, these numbers are going to be either -1, 0, or 1. So, you know, if we happen to be on the x plane, this is going to be 0 here, so it's just going to put it at the z. If it happens to be on the z plane, this is going to be 0 here, and and this will just be on the same plane. So this will allow me to move it one way. You know, this way you kind of just shift it off down the end of the track so that it meshes itself perfectly at the very end of the track. And then, of course, the little physics imposter here with a giant size friction. Let's save it. Let's flip over to the browser. And there's our stop gate. Perfect. Now what I could have done probably is move the Y up maybe half the height of the gate. You know, whatever. It doesn't really matter because this will be more than enough to stop the cars once they get there. Again, and this is a proof of concept. Alrighty, we've got that. So let's now draw that gate. It's in 4 parts. We got the 2 columns on either side, and then we got the arch part at the very top there, and then we got the green line down the middle, which we will use in our next series of videos to be able to determine when these cars have hit the finish line. So let's pop that very first one in. This will be the first column. No big deal there. Okay. Oh, and one thing I meant to mention here, and I just saw it right here. We are doing a texture of the checkerboard that we're applying a new material of the checkerboard up to for these ticker messages. And this is the same type of material that we added when we did the cars here. And we've got that right here. But basically, once we create the box, we pop the material on there to give it that nice, you know, wallpaper hanging of a checkerboard. I have already moved in the checkerboard.jpg on the left-hand side. You can see it right here. I've already moved that over into our project here from my FWJS.race. So I'm not going to worry about that. That just basically gets us our checkerboard. Here's the important stuff. All right, I want the height of each column to be 4. So that's going to be plenty of height above the column itself. I want the depth to be 25, just something very simple. And I want the width to be 1. This is going to be the width. As you're looking at it, if you're going down the track, as you're looking at it, the width will be the width of what you're seeing there, and the depth will be as you cross it. If you look to your right or to your left, you will see the depth of the checkerboard itself. All right, we're going to create the box. That's no big deal right there. Give them the material. Here's the position. Now, here's something that's very interesting. Notice here, I'm starting at the next to last point, X, Y, and Z, which is perfect because that's where I want the arch. I want the arch exactly at the finish line, and the finish line I've determined is going to be at the next to last point. All right, so the next thing I want to do is I want to move it off to the side because, again, the XYZ is right smack dab in the middle of the track, so we don't want that. So we want to move it off to the side. So I'm multiplying it by the track width times the forward vector times -1, because that's going to move it off to one side. When we do the other column, we're not going to multiply by -1 because that will move it off to the other side. So it just allows me to do it from one side to the other. But I want you to notice something interesting here. I'm determining X, but I'm using the Z forward vector to multiply it by. Or I'm using the center Z, but I'm multiplying it by the forward X. Why in the world am I doing that? Well, best way to show you is to actually demo it. Let's put this back to X and Z. You know, because this is what you would normally do. It's what we've done for all the rest of these, like the stop gate up here. We did the X, the forward vector X times the X, the forward vector Z times the Z. We did the same thing with the starting gate earlier. So let's do the same thing here too. Let's save it. Let's bring up the browser. And there we go. And that's what happens. So notice it did take it away by the track width from the center point, but it put it right smack dab in the middle of the track. Why did it do that? Well, here's the key. Again, we're starting at X, Y, and Z. Let's just look at X. So let's assume, for right now, let's just assume that our track is on the X plane. Let's just for funs, okay? It's on the X plane. So we're running along the X plane here, and la-di-da-di-da-di-da, we multiply track width times the X forward X, which will be 1, times -1, which will be a -1. So track width times -1. So basically center X minus 4. Now we're on the X plane. So where's that going to move the column? It's going to move it along the X plane. But our track's along the X plane. So what happened? It's going to put the column in the middle of the track. So we don't want to move it along the same plane that we're calculating the point for. We actually want to move it perpendicular. What's perpendicular to the X plane? The Z plane. That's right. I knew y'all are smart. What's perpendicular to the Z plane? That's right, the X plane. Gosh, y'all are so smart. So that's the reason that we switch the X and the Z forward vectors to the Z and the X of the center. By switching those around, I'm now moving it perpendicular to the plane that the track is running. So if we're running on an X plane, it's going to move it along the Z axis. If we're along a Z plane, it's going to move it along the X axis. And by doing that, I saved it, we get this. And that's exactly what we want. We're along this plane, which actually I think is the Z plane, if I remember correctly. This is our positive Z plane. So we've moved it off onto the X axis. That now moves it off to the side. Really cute. Really works like great. Believe it or not, it took me a while to figure that part out. It's just, sometimes it's the really simple stuff that just throws you for a loop. And this was, once I figured it out, I was sitting there going, yeah, that's too simple. So knowing all that, what about the second line? Or the second column, excuse me. Well, here's the second column. Exact same thing here. I've got the X, but moving along the perpendicular plane. Here's the Z, but moving along the perpendicular plane. And notice I didn't say by -1 here. By not multiplying by -1, it's going to go the other way. So basically, it should give me a column on either side. Let's just check that and find that out. I saved it. And sure enough, there it is. Easy, easy, easy. All right, how about that big, nice, pretty arc at the very top? Well, I don't know if it's pretty or not. Prettiness is in the eye of the beholder. I just realized that looked terrible. Okay, there we go. All right, so here is the top part over here. Again, the exact same thing, X, Y, and Z. Now, I do want to keep the exact same X and Y, X and Z because I want it to be centered over the track itself. So I'm not going to move my X and Z. The only thing I want to move is my Y. And I want to move my Y high enough up where I know it's not going to affect anything. So I'm just moving it up the gate height. My gate height happens to be 4. There it is, line 101. My gate height is 4. So I'm just moving it up the gate height. My IDE here, however, is telling me that get width should probably not be assigned to height. I like my IDE. This happens to be WebStorm. It's a great IDE. Sometimes, though, it makes assumptions that you probably maybe make a mistake here. And 99 times out of 100, it's correct, but this time it is not correct. And the reason why is that I want the height of my box to basically be small, or basically the width of the two columns. So everything looks like just a nice, pretty square. So I want the height to actually be the width. The depth is not going to change. The width is going to be track width times 2. That's very important. Why times 2? Because, let's just take this side over here, for example. I am moving the axis, or I'm moving the X or the Z by the track width times the whatever vector I happen to be. So if this one is moved a track width off, which is by default 4, and this other one is moved by the other distance by also track width, which is 4. What's that? What is that? That's 8. What is that? That is track width times 2. Ta-da! So that's why we have track width times 2 right there. That's it. That's a real simple one. So let's just save that. And let's go to the browser. And there's your belows. That's it. All that's left is that green line. Let's pop that green line in there. Okay, and here is the green line. Very, very easy. The finish line is not, instead of using boxes, I'm now called create lines. And when you create lines, you give it an array of points. And I've given an array of points to basically say that, hey, I want the first point to start at a particular place, and I want the second point to start at a particular place itself. Now, then we also give it a colors. I'm giving it a color green for both of the points. No big deal there. To determine the direction vector origin and the direction vector terminator, we're going to basically take both of the columns, which is the finish line left and the finish line right. We're going to keep with the X and Y position, the X and Z positions, but we want the Y position to be just at the right spot where it'll be able to detect anything crossing it. And that's going to be basically take the position Y, which again is in the very middle of the box, of the finished left box, which is about, I don't know, it's a certain distance above it. Gate height divided by 2 above it, of course, you know, because it's right smack dab in the middle. So it's right, So our direction vector origin, which is the very beginning of our lines, is going to the same X and Y, same X and Z. We're going to take the Y, which is, again, it's in the middle of the mesh, so it's basically the gate height divided by 2. We're going to subtract the gate height divided by 2, and that's going to put it at the very bottom of the mesh. Now, the mesh is lined up, actually, with the track itself. So right now, conceptually, that point, if we were to draw a line from one to the other, that point's going to be on the track itself. And I don't want it on the track may mess it up. There may be a little bump or something, and the car may actually bump over the finish line, and we won't see it. So what I'm doing is I'm actually adding the height of the wall. And so this will mean that the green line will be right above or right at the wall itself. So unless they have a really huge jump at that point, then we know that we should be able to realize when a car has crossed that green light. And the same thing for the terminator. So basically I'm defining one position where my line is going to start and one position where my line is going to end. And that will come in very important later on when I do what we call ray tracing, where I'm going to basically, you can almost think about it as firing a laser from one side to the other, and when something crosses that laser, we know something's gone on. And this is the exact same thing here, except I'm going from the other column, and I'm just telling it what points to do and what color they are. Direction vector is something we will be using later on when we implement this within the game itself, because I need to give it some sort of vector about the direction that it is going. So that ray tracing will basically say, okay, I'm going to start at this position, I'm going to go in this direction until I hit this position or something like that. I can't quite remember. We'll find out when we get there. So that's really all there is to that green line. Let's see if it actually works. Let's save it. And there's the green line. So now everything is there. We've got way up there the starting gate, and we got way down here. Actually, let's just, there we go. That works. So there's our starting gate. Ta-da-da. There's our ending gate, the stop gate, and the finish line. And that's it. So our next video, or next series of videos, this actually completes the series of videos on the track. The next series of videos is we're going to put it all together and start racing some cars. If you like this video, please click on the like button below, subscribe to this channel, or leave a comment. I'd love to hear from you. We're trying to get to 1 million subscribers by February of 2042, and so your subscription will be greatly appreciated. Thank you so very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.